Hello, good morning, happy Monday. How are you all today? Today is Labor Day in the United States, and technically is a holiday for many people. I guess now being a contractor, I don't really get holidays. It's just another day here for us. So, yay! Asetsu, hello. How are you doing today? All right. So I have experimented with I played around with the ingrained chat systems you can see above me. I made it permanently available, so when I'm on a web browser like this, it's not super awesome. But when we're coding, I have a little column of stuff that I can use up here. And so as long as I remember that you can't see that, in fact, I mean, you can't see most of them very easily, then we're good to go. I think we'll be fine. You're doing great working on code and making steady progress. Oh, that sounds great. That's kind of what we all want, right? Steady progress. All right. So we finished updating the Axum course last time, and I had mentioned that I was going to figure out what we're going to work on next. I have sort of like a queue of things that we're going through, and one of the next sort of like item was, hey, let's do a challenge thing. Challenge would be nice, get away from all like the just projects and courses and do something fun, challenging for a while. And so I figured, hey, let's do another CodeCrafters one. Now, when I first started with CodeCrafters, before we did the Git challenge, I launched the build your own HTTP server and just went through the first one or two challenges of it. I guess the first one stage. So we're technically on stage 2. And it's just been sitting here on this page every time I come to it saying, hey, you want to finish it? I'm like, okay, that's what we're gonna do. We're gonna make this green like the build your own Git one. So that way it doesn't bother me anymore. Okay. So for those of you who were not here for the build your own Git, CodeCrafters is I've partnered with them, so they have given me VIP access to their entire site. Which does mean that I have that there was a free access for it. They do have sometimes beta courses that they make available for free. So, for example, they have this build your own interpreter sort of. It's not really a course; it's a challenge that you can go and do that for free right now. So, if you do want to sort of check it out and try on your own. Right now is a great time. Every once in a while, they do like a free weekend or something else like that, but I don't see one happening right now. You're sure it will be much easier than Git? No need to decipher cryptic documentation. I hope not. But yes, it hopefully should be significantly easier than Git. Yes. As we can see, there are a lot of other things that are in here that are pretty fun. Like the build your own Redis is a lot of fun, especially now that like a lot of people are moving away from Redis and switching to other things. Sort of like to understand what exactly that means, and what do we want with that? Let's see. The other one, didn't they have a build your own doc? They had a build your own Docker, I think, at one point in time, but I don't see that anymore. So maybe that got removed. But yeah, it looks pretty cool. So. I'll jump into here. I did hit the reset button, so it reset the progress for us. Otherwise, it said that I had already done all the way through here. So let's see. I guess other things are, if you do enjoy this, I have on YouTube a link to CodeCrafters. That does have an affiliate sort of code on it. So if you do make a purchase with that. Then I do get a little bit of kickback from it, and it shouldn't. I think we've checked it; it doesn't like increase the cost for anybody else at all. And let's see, for other things, yeah, I don't think I have anything else. So we're going to be going for several. We have several hours today until around, I think, between 12 and 1 is when I'm going to have to jump off. So let's jump in and get right on it. So. Build your own HTTP server. Introduction. Welcome to the Build Your Own HTTP Server Challenge. HTTP is the protocol that powers the web. In this challenge, you'll build an HTTP server that's capable of handling simple GET POST requests, serving files, and handling multiple concurrent connections. Along the way, we'll learn about TCP connections, HTTP headers, HTTP verbs, handling multiple connections, and more. Okay, so preferred challenge assessment. We're going to go with Rust. They do have a bunch of other languages that we could choose to use, but we're going to go with Rust here. I'll say I'm intermediate. Practice cadence once a week. Accountability. Now I'll pass. Yay, we're done step 1. Repository setup. We prepared to start a repository with some Rust code for you. So we want to clone this repo, and it looks like it's going from CodeCrafters has their own Git server, it looks like. And that's what I remembered from last time, is that pretty much all the fun sort of challengey validation and checking that they do is on their Git stuff, which is really cool. So let's go ahead and pull that in. Oh, that actually included the CD in there. Okay, so push an empty commit. So we want to just create an empty commit here. So git commit, allow empty, message test, and then push this to origin master. Let's go ahead and do that. And this is how CodeCrafters really works for us. Is it then runs our test and says, okay, it compiled. It is then doing the first test, and of course the first test failed, but this stage completed. How to pass this stage, which is binding to a port. Since this is the first stage, we've included some commented code to help you get started. To pass this stage, simply uncomment the code and submit your changes. So navigate to main.rs. Okay, let's take a look at what we've got here. So if we look in main, we have a bunch of this documentation. Oh, sorry, a bunch of this commented code. But we can also just look at what they have us bringing in right now. So they have us bringing in anyhow, bytes, and this error. We have found out in a Git challenge that we are allowed to bring in other things in here, and that does work. Let's see, they have their own little scripts. We're not going to worry about those. They have their README, but for the most part, we shouldn't need to worry about that too much. I believe that it is basically instructions for the entire thing, though. Oh, and then your program is a way for us to manually test what they're going to be doing later on. But okay, so let's see, you can use print statements, logs from your program will appear here. I don't think that I need this at all, so we're going to go ahead and get rid of this. Uncomment this block to pass the first stage. So what exactly is the first stage? We're binding to a port, and they don't, in this stage, you'll create a TCP server that listens on port 4221. TCP is the underlying protocol used by HTTP servers. The tester will execute your program like this. So they'll just call your program.sh. Then the tester will try to connect to your server on port 4221. The connection must succeed for you to pass the stage. Because we're not listening for anything, I wonder if they're going to use something like the old system admin in me wants to say like telnet. Is there anything more modern than telnet for like just connecting to a port? All right, let's go through this because we are uncommenting a bunch of, well, code. Let's actually make sure we understand what this is doing before we submit this. So I'm going to create a listener using TCP listener, and that is from standard net. We're going to bind 127.0.0.1, so localhost, port 4221. Okay, that sounds great. Now, if we were running this in a Docker container, let's say, then we would want to use this as like 0000. And then most likely we'd also want to have the port be something we can bring in via a environment variable. But because we are, well, right now, I'm guessing that later on we're going to want to do something like that. For right now, we're going to leave this sort of hard-coded. For stream and listener incoming, okay, so we're going to loop through all the incoming listeners. Notice that this isn't async await. We are just sort of blocking with everything. We're going to match on what the stream is, which is a result. It's going to be okay, we get a TCP stream or we get an error. And if we get the TCP stream, we have accepted new connection. Okay, great. So what we can do is I can quit you and we can run your program. This should compile my code and then try to run it. And I guess that's it. I took out that print line, so we can't actually see that it's working. So, okay, great. So let's go ahead and send this on up. Now, I don't believe that it matters what message we give for this. So I'm going to say we have uncommented code. That's pretty much it. And now we should see it pass this thing. Compilation successful, test passed. Excellent. So yeah, it ran our code. It connected using TCP. Success closing connection. Test passed. We got this back from it, the accept a new connection. And we're on to the next phase. Excellent. Okay, test passed. We can mark that stage as complete. Ooh, it looks like they've added that. I remember back when we were doing Git, they auto completed the stage for us as soon as we were done with it. But now they make you press a button, which kind of is nice because there's a few times that we wanted to see, hey, does it work? And then do a refactor. And that was, well, nice. Okay. Stage 2, I think. Bind to a port. No. Respond. Okay. Stage 2. Respond with 200. There we go. How to pass the stage. In this stage, you'll implement your own solution. Unlike stage 1, your repository doesn't contain commented code to pass this stage, which would be kind of strange if they just gave us the code the entire time, right? 98% of users who attempt this stage complete it. That's an interesting message. I think what they're trying to do is say, hey, don't be scared. You're okay. Almost everybody who does this gets it. Go ahead and go. It's okay. Okay, step 1, read the instructions. All right, I'm not great at reading, but I'll do my best. Your task card below contains a description of what you need to implement to pass tests. We also recommend taking a look at the Code Examples tab, which contains code examples from other users. The Screencast tab, if you prefer more detailed video walkthroughs. Ooh, I think that's new. I don't remember that being there last time. Mark this step as complete once you've read the instructions and are ready to implement your solution. So, looks like these are not necessarily from them. Yeah, submit a screencast. Cool. And then Code Examples is everybody else who has submitted something. So, for example, I think I've actually I did this 9 months ago as sort of like an experiment on my own. So we're not going to read my own code from back in the day. We're going to do it ourselves. Okay. In this stage, your server will respond to an HTTP request with a 200 response. HTTP response. An HTTP response is made up of 3 parts, each separated by a CRLF. So, carriage return line feed. Is that what it is? So basically, this terminology, the RN here, this comes from back in the old days when we were using typewriters, because it is possible to hit return and it would move the paper up. So you're on a new line, but the print head, the thing that's going to actually punch the letter into the paper, was on the same column. So you can just create, it's easy to create more columns down. It's easy to create, fill out forms, do that kind of stuff. It's great, right? But if you want to go back to the beginning, you slap the little lever on the right, and then it moves it all over to the left, and then ding, and it was great. For those of you who have ever used typewriters, you'll recognize that. That has stayed with the programming community here. And so we now have to say we want to go down and left all the way. And that is the RN, is both of those together, otherwise known as the CRLF. Okay, so each separate by a so status line, 0 more headers, each ending with a CRLF, optional response body. In this stage, your server's response will only contain a status line. Here's the response your server must send. So HTTP 1.1. So, well, we're going to be responding HTTP 1.1. Okay. The 200 status code, and then the OK, which is the message that comes with this. And then we end. And then, of course, that's the ending for this. And then, of course, the very end has another one. So that's why there's 2 CRLFs here. Here's a breakdown of the response. Right, and that's exactly it. Oh, yeah, and headers go in between there. So that's also the other thing. We have OK, that, headers, which we have none of, and then end of the headers. Tests. Okay, your tester will execute your program like this. The tester will then send an HTTP GET request to your server, which is like this, the curl verbose, I want to say, to localhost 4221. Your server must respond to the request with the following response. Note, you can ignore the contents of the request. We'll cover parsing requests in later stages. For more information about HTTP responses, see the MDN web docs and HTTP responses. Okay, excellent. So let's go ahead and get our test set up for this. Now, I don't necessarily need to write automated tests for every single one of these stages myself. I think that if we do a sort of like a manual test for this, I think we'll be fine. So let me go ahead and set up something below chat. Oh, and that's perfect. It's like a perfect spot there. So if I do wasn't the curl. Let's copy this curl and we'll throw that in there. So right away, I get a connection refused. So you can see that behind me. So what I'm going to do is now we're going to, well, actually, you know what? If we run this and I run this one again, trying to connect, we got the connection, but we shouldn't get anything. Yeah, attempted to, let's see, localhost was resolved, connection refused, because I don't actually have anything on /. And we don't even get a 404 error because, well, we have to write that ourselves, don't we? Okay, so we kind of know that this is going to work. So we're going to have to figure it out ourselves. Let's head into main. So one of the things that we learned from the Git is the Git challenge is that we should probably start thinking about abstracting things out or moving things into other files sooner than later, and then just if it feels nice, just like put it into its own file and deal with it there, because we end up reusing a lot of things. That's what sort of like what we found earlier, and then that way we can sort of program in the more Lego mindset. Okay, so what exactly does that mean? Also, I have some neighbors are doing some construction. Can you hear any of the sawing that's happening? It feels pretty loud to me. I'm gonna go ahead and close my window. No, you can't hear it? Okay, excellent. It's like I'm glad that the mic doesn't pick that up. It's less nice though that that I can pick it up. I guess I could wear headphones, but I don't want to wear headphones. All right, so what do we want to do? So maybe we like make it work here first, and then we'll go ahead and do the next thing. Inheritane, hello, how are you doing today? We are making a HTTP server in Rust. We're using CodeCrafters as our sort of guide for this. Okay, so I have this new connection like this. Now, if I want to just say, no matter what I do, I return a 200, we can change you. And if let's see, how do we respond? I don't want to look at these right away. What we need to figure out is what I can do with this stream to get a response, because it's not going to be like just a return, right? It's probably going to be something like stream dot, and then I can maybe send something. So I could write something to it. Christopher, hello. How are you doing today? Are we at the beginning of the project? Yes. So we have so far, we are working on respond with 200 here. So we previously did bind to a port, which is where we got all this code. And then this is the first of the code we have to write ourselves, which is the respond with 200. What's nice is it looks like they removed the AI actual suggestions, which is nice. They do have concepts. Oh, interactive tutorials that teach you fundamental concepts related to this challenge. Oh, that's nice. If we need to, we can look through those later. So I would guess that write might be what we look for. And then we might need a flush too. So let's try a write. Takes in a self, and then, a U8 but that should be fairly easy to do. So let's do our response equals. All right, now if I just hard code this. Oh, Nigel. Oh, I completely missed your message. I'm sorry about that. Nigel Ruthrow, hello. How are you doing today? Is this TCP listener blocking? Yes, this is absolutely blocking here. Basically, in Rust, if we don't see an await or like an async await, or it's blocking. That's pretty much it. I am an expert at missing messages. I am. I absolutely professional streamer here with a slow chat. Yeah. But yeah, so my guess is later on when the challenge moves into concurrent requests, this is going to be either doing something with async await, but more likely doing something with threads, and maybe even creating a thread pool or something like that. It's going to be interesting to see if they suggest Tokyo or if we do something else. My guess is it's going to be just a manual threads. That's all I can imagine. But okay, so response. We need to respond back with this. HTTP 1.1. So now if I copy you, so HTTP 1.1, that's our protocol. We have our 200, which is going to be our code, HTTP code. We have the message that goes along with this. That feels like this could be an enum or like a static lookup or something. We have our new lines, our carriage returns, CRLFs. And then we have this sort of space here for headers that nothing is happening in. And then, of course, body can go after that. But again, this is empty. So if I do that, and then we do a stream write, and then we have a buffer. So that's a reference to a bunch of U8s. So as bytes, which becomes a reference to a bunch of U8s. Now, as bytes, it's just as fine. And then write, what do you return? You return a result. So could we, now we have anyhow. But we're in main here. So I guess for right now, I'm going to unwrap this, but we're not going to want to remain it unwrapped for long. And then let's make you mute and see if this just does what it is. Now, I haven't actually, it's been 9 months since I did this stage on my own. I've completely forgotten everything about it, so we'll just figure it out. Why did I choose to learn Rust over other low-level languages, say even C? Yeah, it's a good question. So when I was teaching, I was doing a lot of JavaScript teaching, and I was like, it's been so long since I've done anything new. Let me relearn C or do something low level. And I bought a C book. I still have it somewhere around here. Actually, I literally have it holding up the monitor that I read chat in. And I was talking to some of my coworkers, and they're like, well, why learn C again? Why not learn one of the newer low level languages like Rust? And back then it was before 1.0 with Rust. And so I'm like, let me think about it. But I had several people who were there who knew Rust and were, very happy to be mentors for me in the learning journey. So I decided, okay, we're going to do it. I went to some meetups that were in Rust. It was the community was really awesome. And so it's like, okay, let's do it. And then I learned live on stream, going through the book. And I think I waited until 1.0 before I actually started learning properly. But that wasn't very long. It didn't take very long before Rust sort of released, as it were. So that's the real reason of why. It was because I've done C in the past, back when I was in taking college classes. And then after that, it was just access to mentors who knew Rust. Because I do believe that if you're going to learn a language, having access to people who know that language also and kind of help you out is extremely important. I should put a Rust book under that monitor. It'll be the Rust Foundation. Yes, I should. I don't actually have a physical copy of the Rust books. That would work out though. Right now I have, let's see. I have a leadership book, programming in C, a random ecology book, and then a bunch of Dungeons and Dragons books. So those are all what's holding up the monitor. Okay, physical books. What are those? Yeah, exactly. They're monitor holders. That's what physical books are, right? Okay, let's see if this works the way we expect it to. So if we go ahead and we run this, this is probably an easier way of me setting this up. So we'll do your program to run you, and then you know what I'm thinking? I should do your program to run you over here. Oh, am I not in the right? I'm not in the right directory. Okay, get that going. And then over here, let's do our curl. And I believe this is what we got back out of it. So I think that works the way we expect it to. Now, theoretically, if I submit this and it passes, it doesn't like move us on to the next stage, which is exactly what we want now. So let's test that out. So if I commit and we just say responding with 200, okay, let's find out whether or not this passes. There we go. Okay, test passed. Notice also that for every stage, it also checks this out. Write is not enough on its own. It doesn't guarantee writing all provided bytes in a single call. Oh, really? Okay. So I'll probably need write. Oh, do I need like write all or something? Or do I need to write in flush? Because I could also stream flush. Flush this output stream, ensuring that all intermediately buffered contents reach their destination. So I could do that. This is a self. There's also a write to end. I don't see a write to end. There's a write all. Attempts to write an entire buffer into this writer. This method will continuously call write until there is no more data to be written or an error of none. Okay. So this could also, yeah, write all. Okay, so let's do that. Now if I do write all and I do unwrap and what do I have here? Oh, it's a result of nothing. So I don't have anything more. So if I do a stream flush and we unwrap you. Now, my guess is that I probably don't need to do both of them, but if I want to be extremely sure that everything is written out before we move on to the next line, then write all and flush would probably be the best bet. So if I do this, I should probably do a cargo watch on this code over here. There's my curl. Everything here works fine. Okay, great. Now, that being said, I think that it's time for us to start figuring out a better structure for this code because everything in main is going to be kind of not great. And I really don't want to keep these unwraps here, but I don't want to have a return result on main because I don't know, like I know that they allow it, but I don't like it, if that makes sense. So I'm thinking we create let's go to source here. I'm thinking that we're going to create a library file. So there's lib.rs, and I could probably throw this into there right now because I don't know the rest of like where to put this. We can probably just throw everything in here right now. Now we do need to put this inside of a function though. Duncan Stamp, hello, how are you doing today? Do I play D&D, Dungeons and Dragons? So I have played D&D a lot in the past. I both as a player and a dungeon master. What I found is that it's so hard these days to find like a group of people that I know. Like I know that I could go online and find sort of like some random people to play with, but getting people that are sort of like-minded, friends with me that I know in real life, or at least, you know, online, and to do some kind of like gaming, yeah, it's rough. I look like a DM. What does a DM look like? Would a Star Wars evil D&D campaign political strategic theme? I don't know. Right now, I have this entire universe campaign world that I'm sort of like building out in my head. Because if I can't run any like campaigns or do anything else, at least like doing world building is a lot of fun for me. So I'm actually wanting to, like, I've been working on figuring out something to do with maybe some kind of like async D&D with a community or somebody else. I'm running a ex-coworker through a really like basic one shot that I've created just to see whether or not some async type stuff works at all. And I don't know. We're about to get into combat with that one, and it's interesting. So probably right now, I don't think I want to join in as a player. But thank you so much for the invite. Okay, let's take a look with this. I want a pub function. Let's just do this as run, and we don't have anything to return right now. And I want to return a result. Let's return an anyhow result. And in this specific case, I don't think we have anything to return. So it'll be like that. And we will take all of you, throw you in here. Okay, and you're going to yell at me because we don't have any of this stuff in here. So let's import you. Listener, incoming. Okay, what are you upset? Oh, you're upset because we're not returning. Okay, like that. Excellent. Stream that right all. Looks like we have a trait to import. So we want import right probably. There we go. We do that. Excellent. Now, instead of this unwrap, what we want now to do is to convert this into a question mark to have it then send out. But what we can do is we can add context into it to say like, hey, what are we doing? So we are writing all response data and then question mark, and then you are context flushing right so that everything goes out and question mark. Okay, so then everything here should be fine for right now. We're gonna have to go back into main and call run. So let's match run, which of course you don't know what to do. So we have to use, what is even this thing called? CodeCrafters HTTP server, which meant to just Y that. You become lowercase. I wish I could do like the tilde trick for that, but I can't. Like lowercase the dash, please. Okay, so use CodeCrafters run. And so I can match run. We do that. We're going to have an okay. This has nothing inside of it, so we don't really care. And we are exiting at this point in time, so we can just do a print line and just say server exited. We don't really care at that point. And then error, however, is going to be more interesting. I probably want to do, let's see, do I want to do a couple things? I think I do. I think I want to say an ePrint line where we're going to have an error. Do I care about what exactly like to put an error like this? Probably not. I might just want to do an ePrint line error. So print that out to standard error. And then we want to exit. So I can do a exit with code. This type represents the status code. The current process can return to its parent under. So I think I could just exit code and we could just say one, whatever, because we don't, as long as it's not a 0, that's an error as far as the shell is concerned. Okay, so I think that should be good. Let's go ahead and rerun this and make sure this works. And there's our curl. Okay, so everything is still good. Excellent. Let's see, what else do we have? Do I have a Discord? Yes, I do. And then Skimus, hello, how are you doing today? Thank you for the section. Oh, there was an ad there. Okay. Oh, sorry about that. Let's see. I don't know what I was talking about when you got the ad because I wasn't paying attention to the ad screen over there. So sorry about that. Let me know what it was and I can re-say it. Or did you get the, I also have, I think a Discord, do we have that? Oh, it's not slash, it's bang. Does that open up? Yeah. So that's another way to get access to Discord. Nigel, you just learned something new about Helix. What did you learn? I was going really fast. So I don't know what thing I went over. Okay. Oh, tilde. Yeah. So tilde with this thing, like where I can. Oh, I was doing search and I was like, why is that so weird? Yeah, so I can make things upper and lowercase with a tilde. Something really fun is that's not only a Helix thing. If you're doing any kind of Vim like, so if you're on VI, Vim, NeoVim, probably any other the other Vims too, like AstroVim, and there's hundreds of flavors. That should all work by default too, unless of course you're working with something that has changed the default control scheme, which in that case, it's somewhere on your keyboard. Who knows where it is? Okay, so this is now our main. We are, this makes it pretty simple. We don't have anything to pass into it, which is great. In the library, we are no longer unwrapping, which is also nice. Now, I am setting up this response like this, and this is sort of like, I don't want to call this the header, but this is like maybe a prefix or protocol, perhaps. Now, everything is going to get this, right? And I wonder if I want to like create a function to hold something like this on, because we're going to want to write all and have response, but I'm going to want to sort of like put together into like this header, like the status code, the message, and then CRLF, and then headers, and then body at the very end. And I'm wondering if I'm going to want to do something like a create response function that sort of builds this up. I don't know. I'm going to put in a message here, like probably want to turn this into a create response function at some point. Now, once we have this response, then the rest of this should be fine, right? We're just going to write this. We're going to write this. We're going to make sure that it flushes and gets all sent out. And then this error. So this is interesting. Do I actually care about printing this error here or not? Because I don't know if I do. Now, this just prints it to standard out, which is not great. And this is for me listening to incoming events. So the server should absolutely crash if this fails, which makes me think, instead of matching stream like this, we should change this to be something more like, we can shadow the stream. So stream equals stream question mark. So I could do something like that. That then takes this error and then just sends it on out through this result. There isn't a way for me, wait, can I just do this here? No, I can't do that at this point as part of you. And I don't think I can put the question mark in here. That'd be weird. So yeah, I think I need to pull it out at this point in time. Although I don't want to unwrap it here. Yeah, because like, okay, so this is an iterator, and then each iteration, so we have multiple of them, is going to be a result. Okay. So that's let's get rid of our match and you, which means I don't need okay mute stream like this. Get rid of you. We just want to take this response stream, so we can question mark you there, and that's great. And then you need to be mutable. If you need to be mutable, wait, you don't need to be mutable? Oh, stream moved due to this method call. You could clone the value and consume it. So I could try clone. Oh, probably clone beforehand. I could okay this and get it out. Is it the result that I've lost? Okay, hold on. Let me try this. If I do that, now you need to be mutable. So that's what it was. Okay, so basically the result was attempting to clone over and over again, but I don't care about the result itself. So we're just going to shadow stream and extract out the result here, and then get access to that. Okay, great. Now we can use those to here when we write all and when we flush, and then we figure out our response. So it's a little bit easier to look at, a little bit less indented in, which is nice. Okay, so I think for right now, this is the only part where I'm very certain we're going to be refactoring this shortly, but I don't exactly know how I want to do that right now. So I'm going to go ahead and leave that. Let's go ahead and re-push this up. All right, so git commits, and this is refactored logic into live.rs. And it should still say that we're passed. Yes, excellent. Now we can mark the stage as complete.